Okay, we've been working with graphing linear inequalities in the plane, and we're going to move towards graphing systems of linear inequalities in a coordinate plane. And just like when we looked at linear equations and systems of linear equations, we would graph both lines and find the point of intersection. In a system of linear inequalities, we're going to graph both inequalities and look for points of intersection by looking for points of overlap in the shading. So I want to illustrate what we're talking about by graphing these two inequalities on this coordinate plane and looking for overlap. So since these are both written in standard form, the easiest way to graph them is to identify x and y intercepts by plugging in 0 for each variable. So when I plug in 0 for x, 2 times 0 gives me 0, and I essentially end up with 3y equals 18, which gives me a y-intercept of 6. And to find the x-intercept, I'm going to plug in 0 for y, which essentially makes that 0, and I get 2x equals 18, divide both sides by 2, and I get an x-intercept of 9. I'm going to do the same thing for this function down here. I'm going to find x and y intercepts by plugging in 0 for each variable. When I plug in 0 for this x, I get negative 4y equals 12, which gives me a y-intercept of negative 3 when I divide both sides by negative 4. When I plug in 0 for y, I get an x-intercept of 12. So one of the things I noticed in looking at my graph here is I'm not going to be able to fit 12, 0 on this graph by going by ones. So my scale on my graph is going to have to go by 2s. So let's see, my first equation, the y-intercept is at 6. The x-intercept is at 9. So those are my two intercepts, and I need 2 points to define a line. It's a less than or equal to, which means I can draw a solid line. So I'm going to draw my line. I have arrows because this line will extend forever. And now I need to look, and before I graph my next line, I want to identify the shading that I would do on this line. So I'm going to pick a test point. I'm going to pick 0, 0. I'm going to plug it into this and see if it makes it true or not. If it makes it true, I know it's part of the solution set and I can do my shading below. If it does not result in a true statement, I know it's not part of the solution set and I need to do my shading on the other side. So 0, 0, 2 times 0 is 0, plus 3 times 0 is 0, and 0 is smaller than 18, so I know this is part of the solution set. Now, instead of doing my shading, what I like to do is draw arrows pointing to the direction I would shade. And I'll show you why here in a second. So I know if I was going to shade, I would shade on the downward side of this line. So on my next line, I see that my y-intercept is at negative 3. My x-intercept is at 12. And since it's a less than or equal to, and I've got that equal to, I can draw a solid line again. Put my arrows, because this guy extends. And let's say I'm going to test 0, 0 again. And 0, 0 lies above the line I just drew. So 0, take away 4 times 0 is 0. And 0 is less than, certainly less than 12. So I know that 0, 0 is part of my solution set. It lies above the line I just drew in, so I know my shading is going to be above this line. So I'm going to draw arrows like that. What I'm really looking for when I'm graphing the solution to this system of inequalities is I'm looking where shading is going to overlap. And there are 4 kind of areas, possible areas, that I might have shading. This area down here, there's going to be no shading. This area over here represents coordinates that aren't solutions to either system. When I look at this section up here, this contains coordinates that would be solutions to this linear inequality, but not this one. So this would only have shading for this. Similarly, when I look down here, I would shade down here for this linear inequality, but not this one. The one area that I have arrows pointing to for both inequalities is this little wedge right here. My shading would overlap. So that section of the graph contains coordinates that would be solutions to both inequalities. So I'm going to shade in just this section because that's the section that both arrows are pointing to. And again, the reason I like to do the arrows is because then I don't have to worry about shading in 3 sections and making the section that overlaps darker. I can just worry about shading in the one section that contains the solutions to my system.